Hello guys, welcome to my class. Today we are going to design a multi-story building, and we are going to design slab, beam and column also. So at first open STAAD Pro. Go to new project, click on space. You can give a name and you can choose the location. Length unit will be meter and force unit is kilonewton. Then click on next, click on add beam and finish. You have to create the building first. It will be a 6-story building and the room size will be 3 meter into 4 meter. So I first create a node first. So click here and click switch off the snap node beam. Click here, close here or select it and it is closed. Now we are going to copy the node by 3 meter distance to 5. So we have to go transition, repeat in X direction. Step will be 5 and spacing will be 3. Then click on OK. As you can see, there is 6 node, 3 meters center to center, and from in the Z direction we are going to create also node. Center to center distance will be 4 meter. So select the node and go to repeat. Then Z direction north step will be 6 and the spacing will be 4. Now the room are created. Then click on front, click the total node and we have to give the foundation. Foundation will go in the y-axis, so copy the node by Ctrl C by your keyboard and paste the node. Ctrl V from your keyboard in y direction. Foundation will be 2 meters, so give 2 in y direction, then click on OK. Now we have to join the node by add beam. There is shortcut to join the nodes. Select total nodes and go to geometry and go to connect beam along y-axis for the foundation, and go to front view and select the nodes, upper nodes for creating beam, and go to geometry, connect beam along x-axis and z-axis. Okay, the floor is created and foundation is created. Now we have to create the slabs. So for that we have to go to generate surface meshing and select the corner nodes. Click here, then corner nodes and it end here. It is a quadrantal machine, so click quadrantal, then OK. As you can see, the length is 15 meter, spacing is 3 meter, so division will be 5 meter. It is 24 meter, spacing is 4 meter, and the division will be 6 meter. Then it is same 5 and 6. Then click on apply. You can check by beam cursor, plate cursor. Now this has been converted a plate. Okay. Now you have to fix the columns. So go to support page, create a support, it is fixed support, then add fixed support, select the fixed support, go to front, select the nodes and assign the selected nodes. Click on assign, then the node are assigned fixed, and you have to keep the property for the beams and columns. So go to property page and go to define. Column will be 500 millimeter, so 0.5 meter and 0.5 meter. Then click on add. Floor beam will be 0.300 0.3 meter and 0.3 meter. Then add. The roof beam will be 0.3 by 0.25. Then click on add, then close. Okay. Now for the slab, go to thickness. Plate thickness, it will be a 200 millimeter thickness. So give 0.2 meter. Then click on add, close. Select the column property. Go to select. For selecting the columns only, go to select beam parallel to y-axis. As you can see, the column is selected, and for assign to selected beams, assign yes. For the beams, the geometry, select beam parallel to X and Z, and click on assign yes. For the plate, go to plate cursor, go to front view, select the plates and go to thickness, select the plate and click on assign. Okay, all are assigned. You can check by 3D view. As you can see, all property has been given. Now we have to give it a 6-story building. So go to front view, select the geometry cursor. For total property has to be copied by geometry cursor. Select the beams, plate, and go to transition and repeat. It will be 6-storied. Minimum step will be 6. Spacing will be 3 meter, and they are linked. They will be linked. So click on link. Link step will be we are going to link by a beam. Click on OK. As you can see, the floor has been copied. The floor has been copied, but the beam columns are not copied by geometry cursor because we copied just the beams and columns. Now I have to keep the property. So select the column property, go to select beam parallel to y-axis, go to front view, deselect the assigned columns, or you can select by controlling from your keyboard. Pressing control from your keyboard, select the columns and click on assign. The property is given. For the roof slab, I am going to give this property. So select the beams, select the property and assign to selected beams. Okay. Then I have to give load. Click on load page, click on load case detail, click on add, click on primary load, dead load. Title will be dead. Click on add. Live, click on add. Click on dead, click on add the self weight, the y-axis, and it will be -1 always. Member load, uniform load. For the floor beam, load will be -16.5 kN in y-axis. Click on add. For roof beam, it will be 5.3. Click on add. -5.3. Click on add. Close. So select self weight. Self weight goes to total building, total structure. Click on ascend to view. Click on the weight. Select the floor beams by beam cursor. Pressing Ctrl from your keyboard. Deselect it just. Okay. Then assign the selected beams. Go to floor load. Select the floor. Click on assign the selected beams. It is been assigned. Then goes to live load. For residential building, member load will be -2 or 3. Then give 2. Add, close. Select the floors, or you can go to select beam parallel to X. Select beam parallel to Z. All our XY direction is been selected. And click on assign selected beams. Assign, yes. Okay. For the floor, click on dead. Click on add. Click on floor load. Pressure will be -5. Click on and define the range. The range will be this portion to this portion, this floor to this floor. The floor dimension is 2 and this dimension is 20. So minimum will be 2, maximum will be 20. Then click on add. Close. You can see the load has been given. For live full load, click on floor, give -1. Range is same, 2 to 20. And close. This also has been given. You can delete the loads by selecting the load and delete it. Okay. Now go to analyze. You can analyze it. Analyze, no print. Okay, analyze, run analyze, or you can go to Ctrl 5. If there is no error and no warning, then the drawing is perfect. You can see there is no error, no warning. So the drawing is perfect. Now we have to design the RCC reinforced. Go to design, go to concrete. Kind code will be IS456. Select the parameters, clear, FC and FY mean, and OK. Now define the parameters. Clear core will be 25 mm, so in meter 0.025, then click on add. FC will be 20,000, and FY mean will be 415,000. Click on it. Now just assign to all in the all structure. So assign to view, yes. Assign to view, assign, yes. Assign to view, assign, yes. Now you have to comment. Go to beam, design column, and design slab advertisement. For design beam, select the only beams. For that, go to select beam parallel to X, select beam parallel to Z, and click on assign to selected beams. Okay. For the column, select, go to beam parallel to Y, then click on assign, then yes. For element, or you can say beam, plate, click on plate cursor, go to front view and select the plates. Okay, then click on assign to selected plates, assign, yes. Now you can analyze it. Go to command, analyze, click on analyze, run analyze. Set. It may take a minute. You can see there is no error and no warning, so our enforcement design is perfect. Now then go to the output file, select the result, concrete beam. You can have the output file. You can see the bottom reinforcement, top reinforcement, okay, shared reinforcement. There is all the data has been given. Okay. Just you can collect the data and give your customer. Then go to post processing. Okay. Go to plate. Stress type will be maximum absolute. Click on OK. You can check the stresses. See. You can check the reaction for columns. Now for the design you have to collect all the reaction for the beam and you have to create a table, or you can have the table here. Yeah. As you can see. Okay. You can change the animation for deflection, like okay, for dead load. It has been moving. Okay. You can check the RCC design by selecting the beam. You can see top reinforcement is 2 nong 10 bar, bottom reinforcement is 2 nong 10 bar, stirrup is 8 mm bar. Okay. For column, double click on the column. You can have the concrete design. total area, you can have the total area, AST, and you have the bar, 8mm bar. You can check the shear, bending, loading, deflection, all the data has been given. And you can check the axial force, how its work reacts. You can check the shear force in y direction. In z direction. You can check the bending y moment. Bending z. You can check the torsion. All the thing we have needed, it is here. Or you can the report, go to report and select what you need. Okay, just select what you need. You can have the picture, click on OK, and you can have the picture. Okay, so that's it. That's how we're gonna design a RCC multi-story building, and keep practicing. So thank you for watching my video.